Hello, my name is Elena Nesson, and it is a pleasure to present our work today at the second workshop on ethical considerations in creative applications of computer vision. We present a novel system for data augmentation, which uses the semantic knowledge about the items in the training dataset and automatically proposes the data points and novel data instances to improve the dataset for next neural network retraining. We use it on the computer vision dataset example, and the preliminary results show that with this approach, the performance of the neural network increases while the level of bias and imbalance in the dataset decreases. Our use case focuses on the real-life project for video object detection and recognition. Such dataset can suffer significantly from data drift problem, which leads to performance degradation and to the bias increase in the operation of the neural network. And even though the novel data instances are statically generated, when the dataset is augmented, they make a valuable addition to the original dataset. And this method is especially useful for the computer vision projects where acquiring of the labeled data is very costly and time-consuming. And of course, when the data is not well prepared, it introduces a variety of problems into the entire machine learning pipeline. One of the first and foremost problems is bias. We define bias as a systematic error and an unexpected tendency to favor one outcome over another. Sampling bias is the result of using the dataset which does not describe the world properly. The dataset can skew over time. For example, if the environment conditions change. So for example, in our project, which analyzes multiple surveillance cameras in the city of West Lafayette, we trained a feature extractor to understand better the contents of the BTO for accelerated content search. However, the seasonal changes in the clothes that people wear caused the initially well-performing model to degrade. Over time, as there appeared more of the clothes of the summer season as opposed to the fall and winter season, which was used initially for training the dataset, the performance of the model dropped. To resolve the problems and to avoid another round of collecting and annotating the data, we apply the SynGen framework. We augment our initial dataset, which is lacking the important data points at this time, with newly generated examples. And we generate the examples using the GAN neural network, namely StyleGAN and DALL-E text-to-image generator by OpenAI. To make the process of augmentation and generating of new instances as independent and as abstract as possible, we use a knowledge graph that allows us to select the entities which we want to use for dataset augmentation. How does it work? Very simple. We know the initial classes that were labeled for feature extractors, and we use it to retrieve the related entities. Then we can use the representative images collected from the web as image prompts to create more of similar annotated examples. The dataset is augmented with the new images and the neural network is retrained. With SynGen pipeline, we can automatically detect the knowledge drift which comes with the worsened performance of the neural network, and then expand the dataset with new classes recommended by the semantic net, for which we generate training images to augment the dataset. We apply existing generative neural networks to automate this process as well. For example, DALL-E text-to-image generator can automatically provide a number of images that can be included into our training dataset. And now our neural network can recognize such objects. We have increased the training dataset by 10% with the newly generated images. Then we extended it with new 4 classes. For each class, 65 examples of images were produced. Our results show that the performance of the neural network is increased as a result of the automatic data augmentation with SynGen. Thank you for your attention, and I'll be happy to answer questions and comments.